From polynomials, okay, where an equation is given to you, that equation is ax square plus bx plus c, right? This is the equation in front of you. Now the question is that if this equation, if this polynomial, not equation, basically this polynomial ax square plus bx plus c, this is exactly divisible by, right? Exactly divisible by, let me keep it in a box. If this is the polynomial in front of you and this is exactly divisible by what? X minus 1 and x minus 2. So these are there, this is divisible by once by x minus 1 and another time by x minus 2, then it leaves no remainder, it is exactly divisible, right? So we can say that these numbers into the bracket, this variable, this number x minus 1 and x minus 2 are the factors of ax square plus bx plus c, isn't it? If x minus 1 and x minus 2 are the factors, that means when this will divide this polynomial, this will be this, then this can be equated as equal to 0, right? So this will give you x minus 1 when equated to 0 being a factor, this will give you the value of x as equal to 1, isn't it? X as equal to 1, let us say this is the first value of x, right? After that, the second one is that the second factor is x minus 2, then into that case, when x minus 2 is considered as a factor, then it can be equated as equal to 0, and this will give you the value of x as equal to 2. So x equal to 2. This is the second value of x, my dear friends. Now it's given that when the same polynomial is divided by x plus 1, it leaves remainder 6. The third case is that when this polynomial divided by x plus 1, it leaves remainder as equal to 6, right? This is the data given to you into the question. Now my dear friends, as we said that these are the factors, if these are the factors, because they are dividing this polynomial exactly, we get that when equate with 0, we get the two values of x equal to 1 and x equal to 2. Now when we just put up all these values into this polynomial, you get certain relations between a, b and c, right? Because these are the factors, so definitely this can be equated to 0 and it will convert into an equation. So that means we can say that for x is equal to 1, right? That is coming from equation number 1. Our polynomial ax square plus bx plus c is equal to 0, isn't it? That means if this is a function of x, definitely this is a function of x, fx, right? Then we can say that f of x equal to 1 will give you a into 1 square plus b into 1 plus c is equal to 0, isn't it? And this will give you one equation, that is a plus b plus c is equal to 0. Let us say this is equation number 3. Let us say this is equation number 3. We have already two equations, 1 and 2. Now after this, for x equal to 1, function of x converted into this will give you equation number 3. Now this function of x, for x equal to 2, because x minus 2 is also a factor, and this give you the value of x equal to 2. So this will give you f of x equal to 2. This function will become a into, I mean to say that ax square plus bx plus c will again go to 0. It will be evaluated at to 0 when this value of x equal to 2 will be applied over here, right? This will give you a into 2a square plus b into 2 plus c is equal to 0, isn't it? This will give you 2a square is 4, 4a plus 2b plus c is equal to 0. This will give you 4a plus 2b plus c is equal to 0. And let us say this is your equation number 4. This is your equation number 4, my dear friends. Now, with this, the third condition is given that when it's divided by x plus 1, it gives remainder 6. It's when divided by x plus 1. That means when the factor is x plus 1, this will give you a relation. This will give you a relation. What is that relation? That when divided by x plus 1, that means x is when this will be the factor, that means x equal to minus 1. F of x plus 1, that is implies that f of x equal to minus 1. When f equal to x equal to minus 1, this entire polynomial will be converting as a into minus 1 whole square plus b into minus 1 plus c, and this will give you certain value, my dear friends. What is that value? What is that value? Tell me. That is your remainder. And what is the remainder over here? Remainder is given to you as equal to 6. So this a into minus 1 square plus b into minus 1 plus c will be equated as equal to 6, which is your remainder here, my dear friends. See here, 6. Now this will give you minus 1 square is plus 1. So this will give you a minus b plus c is equal to 6, and this will be your equation number 5. So we have three variables, right? A, B, C, and the question is that what is the value of A, what is the value of B, what is the value of C? So these are the three variables which need to be evaluated, right? So variables over here are three, equations with us are 3. What are those three equations? Equation number 3, equation number 4, equation number 5, right? Three equations. Equations 3, that is equation number, let me write it as I have written. Equation number 3 in the Roman, equation number 5, sorry, equation number 4 and equation number 5. So this you can see variables 3 and equation 3. So are not you able to solve it? Because these three equations will be solved. You just substitute the value. If you substitute the value of a plus c from here, you can see a plus c from here into this, you get the value of b. So we can say that from equation number 3 and equation number 5, from 3 and 5 will give you the value of b as equal to a b plus 6. Let me write it like this. B plus 6 is equal to a plus c, isn't it? Isn't it? B is shifted to the RHS. That's it. So B plus 6 equal to A plus C. And when you put into the equation number 3, what is equation number 3? Equation number 3 is A plus B plus C is equal to 0. A plus B plus C is equal to 0. This is equation number 3. And when you substitute the value of A plus C from here into this, you will get B plus 6. For A plus C, you get the value of B plus 6, and this B again plus B is equal to 0. So this will give you 2 times B plus 6 equal to 0, and this will give you the value of B as equal to minus 6 by 2. Minus 6 by 2. Minus 6 by 2. And that answer is minus 3, my dear friends. Answer is minus 3. This will give you the value of B as equal to minus 3. So this is one of the value which is calculated. So B is calculated as equal to minus 3. Now my dear friends, we have still two variables A and C. What is the value of A? What is the value of C? Let us see. If you consider equation number 3, putting up this value, you again get some equation into the form of A and C. So we can say that from equation number 3, A plus B plus C is equal to 0, and this will give you A plus C is equal to minus B, and B is minus 3. Put it over here. So minus times minus 3. So this will give you plus 3. So A plus C is equal to 3. Right? A plus C equal to 3. And when you just consider maybe again the same equation, or maybe equation number 4, you will be having 4A plus 2B plus C is equal to 0. That is from equation number 4. What is that? 4A plus 2B plus C is equal to 0. I am saying this equation number 4. 4A plus 2B plus C is equal to 0. And this will give you 4A, when putting up the value of B as minus 3, so this will give you 4A plus 2 into minus 3, the value of B from here we substituted, plus C is equal to 0, and this will give you 4A plus C is equal to 6. 3 into minus 2 becomes 2 into minus 3 becomes minus 6. Minus 6 going into the RHS. Now earlier we have from equation number 3 A plus C as equal to 3. And here we have A plus 4A plus C is equal to 6. So when you put up this value over here, A plus C is equal to 3, and just do the subtraction, you can see C and C will be cancelled out, and we will be having 4A minus A, that is 3A is equal to 6 minus 3, that is equal to 3. So this will give you the value of A as equal to 3 by 3, which is equal to 1. So the value of A is calculated as equal to 1, my dear friends. The value of B we already calculated as equal to minus 3, right? So this value and this value is calculated. So A as equal to 1. So this value is done. This value is done. Now what is the value of C? When you just put up into this equation A, anyone over here, A plus B plus C is equal to 0. right? Then we can say that since from equation number 3, from equation number 3, a plus b plus c is equal to 0. That means putting the value of a as equal to 1, b as equal to minus 3 plus c is equal to 0, this will give you the value of c as equal to minus 3 plus 1, that is minus 2 going into the RHS plus 2. So c is calculated as equal to plus 2, my dear friends. This is the third value of the variable, third value, right? C is plus 2. So the value of c over here is 2, right? So here we can see c is equal to 2, right? This is c equal to 2, b equal to minus 3, a equal to 1. So let me write it over here. Maybe here a as equal to 1, b as equal to minus 3, and c as equal to 2. These are the three values, my dear friends, and this is your answer. This is your answer, right? In this way, we can solve any such questions where the factors are given to you, and the questions where it's given that if some polynomial is having it's exactly divisible by these two numbers or polynomials, then definitely these are the factors of the given polynomial. This implicates that this can be equated as equal to 0. This will give you certain value of x. Put off those values of x one by one and get some equations. Here we have the third condition given to us as when divided by x plus 1, it leaves remainder 6. That means putting up the value of x equal to minus 1, the remainder is coming as equal to 6, you can see. So this will give you one equation, and these two values of x equal to 1 and x equal to 2 will give you two separate equations, right? So equation number 3, equation number 4, and equation number 5. So equations 3, 4, 5. Number of equations 3, number of variables a, b, c, 3. 3 variables, 3 equations. 3 variables, 3 equations. Just solve and get the value of a as equal to 1. Here we have solved a equal to 1, b equal to minus 3, and c equal to 2. Thank you so much for watching, my dear friends. Take care. Bye bye. Happy learning. This is the entire solution in front of you. This is the entire solution. As usual, I am writing the name of my channel. @techno_mathics, right?